welcome to the first podcast in the series, Physics for the Everyday Man. Today I'll be discussing one of the widest known, however least understood phenomenons in modern physics, gravity. Gravity was first theorised by arguably the world's greatest ever physicist, Isaac Newton, after he was famously hit on the head by a falling apple, as we were all told as children. Through Newton's investigation into gravity, he created his law of universal gravitation, which states that every point mass in the universe attracts every other single point mass, with the force pointing along the line of intersection. The force is proportional to the product of the two masses, and inversely proportional to the square of the distance between them. This is very simple to understand. It merely states that every object attracts every other object, and is therefore attracted by every other object. This law was first published in 1687 in Newton's work, the Principia. Newton's law of gravitation was accepted as the correct theory for gravitation for nearly 250 years, until Albert Einstein published the general theory of relativity in 1916. Newton's law worked as an approximation for gravity for large objects and large distances. However, it broke down as an approximation for gravity when investigating atomic distances, as it did not incorporate either the weak or strong interaction, both of which will be discussed later on in the series. It also breaks down for supermassive objects which have a very high density. The general theory of relativity is the current description of gravitation in modern physics. General relativity generalizes special relativity and Newton's law of universal gravitation, providing a unified description of gravity as a geometric property of space and time, or space-time. The general theory of relativity is a complex theory to understand, and will be fully explained in a later podcast. However, when heavily simplified, it states that every point mass does not interact with every other point mass singularly. Instead, it interacts and affects the space and time, thus the space-time between the objects, which then interacts with the other point masses. Gravity is a result of the distortion of space-time. This allows gravity to interact with objects with a zero mass, such as light, which has been observed experimentally and could not be described by Newton's law. It also implies the existence of black holes, which are areas of space-time with such distortion that not even light can escape. However, Einstein's theory does not leave gravitation without unanswered questions. As with Newton's law of gravitation, it does not reconcile with the laws of quantum physics, the weak and strong interactions, to produce a theory of quantum gravity. Neither does it explain the origins of the force. It is the origin of gravity which many modern physicists are interested in, and are indeed researching. It is widely theorized an interaction particle exists, which mediates the force of gravity. This hypothetical particle is known as the graviton, which, should it exist, must be massless, as gravity appears to have a limited range, and must also be a spin-2 boson. The spin is a property of a particle, and one in which every elementary particle has. However, it does not need to be understood, just accepted, and bosons are a subset of particles, much like cake is a subset of food. It can be shown that a massless spin-2 boson would give rise to a force indistinguishable from the gravitation. This suggests that if a massless spin-2 boson is observed, it must be the graviton. If found, the graviton would answer many questions surrounding gravitation. However, there would still be ambiguity in the subject. How and why the graviton is emitted and absorbed by every object, how the graviton interacts with the other fundamentals, part forces, and many more. It is these fundamental forces that will form the discussion in the next podcast, specialising on electromagnetism. To learn more about the propagation of light, tune in next time. Thank you for listening.